The next topic is, guys, graphical study of motion. Okay, so before I start, can you tell me the significance of graph, or what is graph, why we use graph? See, guys, graph basically showcase relationship between two or more variables. So suppose there are, this is variables var1 var2. Okay, so if I want to know the difference, sorry, if I want to know the correlation between these two variable, right? So graph is of great use. It basically helps us in finding out pattern. Okay, pattern of movement. It is for better visualization of a case study. So there are different types of graphs available. So I said two or more variables. So for time being, let's go for at your standard, only two variables are required. Okay, so let us take an example of distance time graph first. Let's go through it first. So I have drawn a graph for you. See, this is something which I have drawn for you. So I have done extensive homework for you guys before I start. So this is a graph actually. So let me explain to you what is given. This is a distance time graph. Okay, x-axis, y-axis. Okay, 0 0, it denotes horizon. Along x-axis I am taking t, time, which is in second, it is given. Along y-axis I am taking s, distance. Okay, which is in meter. Fine. And I've drawn a graph. This, see this, observe this green line. Green line is the graph. Okay, so what do you see in this? This depicts the motion of an object. Okay, so now if I ask you, see it carefully. If I ask you, what is the speed of the object is uniform or not, or non-uniform? Can you tell me? Can you tell me whether the object is traveling with uniform speed or not? It's a very simple question, guys. So think about it. So meanwhile, I'm calculating something for you. Okay, so don't see it. Just look at this particular graph. Okay. I think you should be. See, I have drawn the value. I fetched the value of distance traveled per unit time. Okay, so every second I have fetched the value from this graph. Every second, how much the object traveled. Okay, I'm seeing that in first second. See, this is first. Okay, in first second, object traveled a distance of 5 meter. Now you can ask how. So let me tell you how. So this see, this is how we study graph. So here this 5, this is 5, this is 10, this is 15, this is 20. Yeah, so what is the value of s corresponding to t equal to 1? That is t equal to 1 second. It will come out to be 5 meter. This is what I've written, 5 meter for first second. For first second I am saying. In second, right, how much distance it has covered? So tell me. In 2 seconds, actually, in total it has covered 10 meter, but in first second it has covered 5 meter. So in second it has covered 5 meter, right? So similarly, if you see carefully, you will find that in third second it calculated 5 meter. In fourth second it traveled 5 meter. So what do you see? Can you say, do you notice something out of it? That is per unit time. See, per unit time the object is traveling equal amount of distance, 5 meter, 5 meter, 5 meter, 5 meter, 5 meter. I think this is the definition of uniform motion. Do you remember? So let us go back. When an object travels equal distance per unit time. Okay, per unit time, guys, we can say the object is in uniform motion. So now I think now you should be able to tell me what is the nature of motion of this object. It is purely uniform. Yeah, so that is the answer of this question. So now if I ask you, can you calculate the speed, with what speed the object traveled? Yes, we can calculate. The way is very simple. Okay, you just need to know a little bit geometry. So from graph, so if you have a graph available, and if the nature of graph is a straight line, okay, right, if the nature of a graph is a straight line, so speed you can calculate. So your speed will be slope of the curve, right? Just a moment. So guys, you know how to calculate speed? Yeah, we were talking about speed actually. So speed when graph is available, okay, so we can calculate speed, right? Speed is nothing, it is uh, distance versus time, that is d, and this is s by t. Yeah, that means the value which is available on y-axis, okay, divided by value which is available on x-axis, right? So can you guess what I'm about to say actually? What I'm about to say is that the speed is the slope of the curve. Okay, slope of the curve gives us a speed if we have distance time graph available with us. I repeat, if distance time graph is available with us, we can calculate speed, okay, by calculating the slope of the curve. Now in this case, what is the nature of the curve? We can clearly see it is a straight line. So what is the slope in this case? It is nothing, it is simply tan theta. Slope is tan theta. It is as simple as that. Okay, what is tan theta here? You can make choose, you can just draw a triangle. Let us draw a triangle here, where you want. We can choose this little thing from 2 to 4, okay, and we can choose this y values. Okay, fine. So tell me what is available on y-axis. What is available on y? It is 20 here, right, and it is 10 here, so 20 minus 10, so that is 10. What is available on x? 4 minus 2, that is 2. So speed is 5 meter per second. Fine guys. So guys, we are done with distance time graph. So let us analyze motion of a spring. Okay, this is spring, this is its open end. Let us take this open end as a reference point. I am taking this as a reference point. Okay, and now the spring is at its natural length. Natural length means there is no compression or no extension. It is extension is or compression is 0. We denote compression or extension by delta x usually. So it is displacement. So what is the magnitude of displacement? Right now it is 0. Fine. So before we start, just keep in mind one thing: sign convention, plus and minus. Leftward motion is negative. Okay guys, suppose you stretched this particular uh, open end by a distance of say 5 centimeter, 5 centimeter, and this is t equal to 0. T equal to 0 means from here we start analyzing this motion. Okay, at t equal to 0, the position of the open end of the spring is here. So if I ask you what is the value of uh, delta x, magnitude of delta x, or simply displacement. Okay, what is displacement at t equal to 0? So you should say plus 5 centimeter, because right word is positive. Now you just release the open end from this point. We are releasing open end from this point. So what will happen? Now this open end will keep on moving back and forth. Okay, and let us assume that there is no resistance, no air resistance, no resistance offered from surface. Okay, there is no resistance. So ideally it will keep on moving. After reaching here, the open end will go in this direction. Okay, will go in this direction and will get compressed by equal amount. This is delta x. Okay, this is delta x also. So what I am saying, that compression and extension will be equal. Magnitude, basically magnitude will be equal. Magnitude of compression and extension will be equal when we release open end, uh, pre-assuming that there is no resistance. So at t equal to 0 delta x, the displacement of the open end from the reference point is plus 5 centimeter. Fine. Now t equal to, once again, how much is the displacement? Say this open end reached here in a time duration of 1 second. So t equal to 1 second. Delta x is how much? It reached the reference point, so displacement is 0, no displacement. Now t equal to 2 second, what will happen? It'll the open end will be here, so the displacement you will find, it is how much? It is minus 5 centimeter. Now I'm going further. T equal to 3 second, it will again reach at the reference point, so displacement will become 0 again. T equal to 4 second, displacement is how much? Plus 5 centimeter, 2 more times. T equal to 5 second, delta x, displacement is 0. T equal to 6 second, what is delta x? It is again minus 5 centimeter. So actually during the entire journey, this particular thing will keep on getting repeated. That means the open end, the displacement of open end will keep on varying. Okay, and the range of variation will be plus 5 centimeter to minus 5 centimeter. Yeah guys, it is plus 5 centimeter to this minus 5 centimeter. Just pay attention on this. Plus 5 centimeter to minus 5 centimeter. So do you notice something? That per unit time, that means per second, the displacement of the open end keeps on varying, right? So if we draw this particular scenario on a piece of graph, how it will appear? It will look like something this. See, this is a displacement time graph. Again, I have invested extensive amount of time on this, so let me explain it to you. Along x-axis I have taken time in second, along y-axis I have taken displacement in centimeter. Note. So what I'm, let me explain. Should be, I think, yeah. At t equal to 0, displacement is plus 5 centimeter. 0 plus 5 centimeter. T equal to 1 second, displacement is 0, absolutely fine. At t equal to 2 second, the displacement is minus 5 centimeter. See the point is fine. Third second, it is again 0. Fourth second, plus 5 centimeter. See, fine. And this is the repetition. This is the displacement time graph. So if I ask you, you have displacement and time, so you have you know the relationship between displacement and time of this particular scenario. So can you tell me the velocity is uniform or not uniform? Since the displacement of the open end is not constant, it is keep on varying between plus 5 centimeter to minus 5 centimeter, so certainly we can say this is non-uniform. The answer is non-uniform. Fine. It is very simple. And if I ask you to calculate velocity, so would you be able to calculate? I think you should be. See, while explaining this distance time graph, remember I said that we can calculate speed because distance and time, these two variable are given. So speed is slope of the curve. So in the same way, here displacement and time is available. So we can calculate velocity. We can calculate velocity. So what is velocity in this case? Slope of this curve in the same way. So what is the velocity at t equal to 1 second? T equal to 1 second, the position of the open end is here. So what will the value of the slope? It will be this particular 10 of this particular angle. How to calculate 10 of this angle? So let us say this angle is theta. So what is 10 of this angle? You can say 10 pi minus theta. See, this plus this is 180 degree, that is pi radian. So we can say it is, the slope is, sorry, let us calculate speed at 1 second. v1 means we are calculating a speed at time equal to 1 second. So time equal to 1 second, the velocity will be slope of the curve, that is 10 pi minus theta. So it is going to come to be minus 10 theta. So what is 10 theta? Y by x value y by x, you can say. So what is the value of displacement? 5. It will be minus of 5 by 1. Fine. So speed, so velocity will come out to be minus 5 centimeter per second. That means the velocity of this open end, okay, when it reached at the reference point is minus 5 centimeter per second. Now you might be wondering, why minus, why not plus? Yeah, you're right. This is obvious question. See, we have a sign convention. After reaching here, the open end has a tendency to move leftward. So in which direction it is moving? Negative direction. So that's why the velocity is minus 5 meter per second. Quite simple. So after reaching here, okay, Now let us calculate uh, what is the net displacement. Hmm? What is the net displacement of the opponent? Just pay attention. It is don't be scared. Actually, it is not tough. I am trying to explain it in a very simple way. Okay, so just pay attention, don't be scared. So we have started analyzing the motion from here. Okay, so after reaching here, hmm, what is what is the velocity? Once it reaches here, the velocity will keep on decreasing. It will be zero. The velocity will become zero, and now this open end will move start moving in this direction. Okay, so at time t equal to 2 second, the velocity is 0. Fine. At time t equal 2 second, the velocity is 0. So what is the velocity of the open end at t equal to 3 second? At t equal to 3 second, it will reach here. Fine. So again we can calculate the velocity. So here, what is the velocity of this curve? Let us say it is alpha. It is alpha. Okay, are you able to see? This is alpha. So in this case, we're going to calculate, sorry, v2 is 0. You understand? And now we are going to calculate velocity at t equal to 3 second, third second. It will be like y by x. What is the value of y? Displacement 5, simple, 1. It is coming out to be plus 5 centimeter per second. Now again, you may ask why it is not minus 5 second. So after reaching this point, the open end has a tendency to move rightward. That means positive direction. So that's why it is coming plus 5 centimeter. So this is the pattern. This is the pattern which the open end will follow. Okay, while tracing distance from plus 5 centimeter to minus 5 centimeter. Okay, so this is the way we can calculate velocity from displacement time graph. Yep. So now let us see what I have drawn for you in the next few things. This is very simple, guys. This is a very simple example of displacement time graph. Displacement, uh, let us say in meter, you can say it is in meter. Okay, of any motion, don't go for any specific case. There can be a case that displacement is constant. That means per unit time the object has traveled equal amount of distance, right? And other way of saying this is that uh, the nature of the curve, this curve is linear. So linear curve means if the curve is linear, that means the velocity is what? The velocity is uniform. So what it denotes? It denotes uniform velocity. And what it denotes here? Non-uniform velocity. Right? Similarly, there can be a case wherein speed is non-uniform. Yeah, this is very simple to draw. Just 1 second, 2 second, 3 second, 4 second, right? And distance, let's say in first second the object covered 4 meter. In second second it covered a distance of how much? Say 10 meter. And then in third second, sorry, this is not one, this is basically I should write first, second, third and fourth. In third second the object traveled a distance of say 1 meter. In fourth second the object traveled a distance of say 24 meter. What do you see? Per unit time, object is traveling unequal distance, right? So what it demonstrate? Non-uniform speed, right? It is very simple. It is very simple. Now let us analyze this velocity time graph. Now we are done with distance time graph, right? We are done with displacement time graph. We are able to distinguish between uniform or non-uniform motion uh, based on the data fetched from graph, right? Now we have been capable enough, right? So now it's time to jump onto another type of physical quantities. So here there are two physical quantities. Second quantity is time, which is fine. First quantity is velocity. So now we are going to analyze velocity time graph. Velocity has been taken along y-axis, time along x-axis. So in this graph uh, we are showcasing the relationship between velocity and time. See, this is the graph. So what can you say about this? You can easily say that the object has traveled with uniform velocity. See, this is a velocity. I put arrow mark over it. Object has traveled the distance with uniform velocity of 10 meter per second. Fine, absolutely fine. So if I ask you what is uniform and non-uniform velocity, so the answer is uniform velocity. Fine. Can we calculate the distance traveled by the particle? See, before we want to calculating distance, let me tell you one thing. You know what is speed, distance by time, or say leave it, velocity, displacement by time. We have uh, given this, we have this, so we can calculate this. This is very easy. What will the formula of displacement? It will be velocity into time. It is as simple as that. But suppose you are analyzing a motion in which things are happening like this. It is shifting plus minus, those kind of things. So in that case, uh, we should consider on calculating the magnitude of displacement. Okay, magnitude of displacement we say as distance traveled as. Okay, just keep in mind. So you would be given velocity time graph and you'll be asked to calculate distance traveled. So what is distance in this case? Pay attention. Distance is magnitude of the displacement. Let me write for you. It is magnitude of displacement. Okay, so how can we calculate that? Along y-axis we have velocity, along x-axis we have time, right? And v into t, okay, in this case let us talk in terms of magnitude only. So v into t gives us distance traveled, right? Now how to calculate it? This pure geometry. The way of calculating is that you should find out the area of this shape. You notice this is a rectangle, and we all know what is area of a rectangle. Area means distance traveled. Say it is s equal to area of this rectangle. And what is the area of this rectangle? That is v into t. It will come out to be 10 into 4. So the total displacement covered by the particle, okay, is 40 meter. If you are presented with such kind of graph and you are asked to calculate distance traveled by the particle, I think you should be able to calculate now. So similarly, if you have a velocity time graph and it comes out to be like this, and you are asked to calculate the distance traveled by the particle between this time duration t1 and t2, what is the way out? The way is very simple. You need to draw perpendicular on x-axis corresponding to t1 and t2. Go ahead and find out the area of this what area of this appears to be a. Yeah, hey guys, uh, we are done with all sort of graphical study. Now I'm going to ask a very simple question to you. So if I ask you to prove that, just come back to the motion of a spring which we analyzed here, motion of this spring, okay. Basically I'm referring to the displacement time graph of motion of a spring, okay. If I ask you to prove that, can you prove at time t equal to second, like at time t equal to 2 second, the velocity is 0? Prove it from the graph. Can you prove it? Theoretically, we discussed that at t equal to 0, the position of the open end was here. T equal to 1 second, it reached at reference point. T equal to 2 second, it reached minus 5 centimeter, okay, minus 5 centimeter. So what we discussed that the velocity keeps on decreasing, and after reaching here the velocity becomes 0, and after that the object start moving in the right in the positive direction. Yeah, see it. So that's why we said that the velocity is 0. So actually it is very simple. We are moving so what I'm saying that we are moving from positive direction to negative, okay, positive to negative. So it will become mandatory for us to cross the 0 value. It is as simple as that. So if I ask you to prove that value of v2, velocity at t equal to 2 second, is 0 from this graph, from this displacement graph, so would you be able to prove? Hmm? It is very simple guys. See, we can prove it. So let me prove it for you. So v2, we calculated v1, v3, let us calculate v2 also in the same way. So this is what I mean to say. It is, what is this? This should be displacement, okay. by time. So what is the value available along y-axis at time t equal to 0? It is this value. See, so what is this value? This is 5 plus minus of 5 by duration. How much is the duration? 2 second. Minus 5 plus 5, so it comes out to be 0. It automatically comes out to be 0, and 0 by 2 we know it's 0. So that's why the velocity at second, okay, at t equal to 2 second is 0. So this is something I wanted to let you guys know.